Real-world computer programming for kids of all ages. Step 45. Allowing the user to update the states table. Howdy, folks, or kids, or whoever's out there. Up until now, we've populated our states table with data. We've queried it. We've displayed its values on a form, both in a data grid view control at the top of the form and in separate controls at the bottom of the form, even displaying the images pointed to by their paths stored in the database, and the corresponding web page where the book is featured. As an example of the last named things, here is the Florida image displayed at the bottom of the form, and what displays in your browser when you click that image. Prepare to allow the user to update the states table. Now we are going to allow the user to update certain columns in the states table. Most of these columns should not be changed. Most of the columns should not be changed, as they contain facts, and facts are immutable, or should be. Note, the word immutable is not unique to programming, but it is a word you will probably hear more in the programming world than most other places. Like a lot of these words, it means something relatively simple, namely can't be changed, so unchangeable would work just as well. There are 3 columns, though, that contain data that are specific to any given user, namely have resided there, have visited, and notes. If this were a database that would be used by multiple people, this design wouldn't work very well because one person would add data specific to them for those columns, and then somebody else would come along and with one fell swoop overwrite those values with their own. For example, if Billy Goat Butthead were to enter data for those columns, for Missouri, he would enter no to have resided there, yes to have visited, and it notes something like, went to Branson to see Dolly Parton and the Shepherd of the Hills. Then I would come along, enter yes to have resided there, which would automatically also select yes for have visited too. And in notes, I would enter grandfather Albert L.B. Collenborn, born in DeWitt, Mark Twain, born Florida, spent boyhood in Hannibal, lived in Piedmont and the Boot Heel in the mid-2000s. Me, that is, not Mark Twain. My entries would wipe out B. Butthead's as if he had never even bothered to gingerly stamp his cloven hooves on the keyboard at all. The value for the have visited column would remain the same, but that only by mere happenstance, so to speak. So if we wanted to store each user's individual entries, we would need at least one more table to do so, probably 2. A user's table with their name and its ID value, and a personal notes table, or whatever name you wanted to give that table, that would store what they enter for any state they enter data for. This is mainly a discussion for later when we go into relational database design, but for now I will show you a simple version of the structure of what those 2 tables would be. The first one, the users table, is shown with the user ID, a user first name, and a user last name. And then there's the user's entries table, which contains the ID for that table, also a foreign key ID for the states table, and a foreign key ID for the users table that we just talked about. And then the have resided and have visited columns, which are pseudo-booleans. MySQL doesn't have actual Boolean data type, but they use a tiny int with a length of 1 to handle that. And then there's the user's notes, a text property, text data type. The users table here is what is called a lookup table. The user's entries table would store a record for each state that each user entered data for. Again, we will delve more into this type of structure and relationship later. For now, we will simply treat the states database as if only one person will ever use it. It is their own personal data playground. So how to update the states table if the user enters data into any of those three controls: have resided there, have visited, and notes. First, we have to make those controls visible. So go to the form's load event handler and change this code, visibilize user controls passing false, to this, visibilize using controls passing true. Now, when you run the app, those controls are visible. And a screenshot shows that. The next thing we need to do is to write the code that will enable the update button. It's visible, but it's not enabled. Then we will write the update button's click event handler to update the appropriate columns in the states table for the row that holds the current states data. Note, there is one more property on the controls we should set first. As for the read-only controls, it doesn't matter, because there is no reason for the user to be tabbing through them. But they may want to tab through the controls they can modify, so we will set the tab values of those controls. Set the tab index of checkbox lived to 1, checkbox visited to 2, and rich text box notes to 3. You can also set focus to the first checkbox at the time it is made visible in the Visibilize User Controls method by adding this line of code at the end of that method. If visibilize, checkbox lived.focus. Now we will write some code that enables the update button once there is something to update. That is, after the user has checked one of the two checkboxes, have lived there or have visited, or entered anything in the notes rich text box control. Double-click checkbox lived. Add the following line of code to its default event handler that opens in the code window. Checkbox lived, checked change. And it's two lines of code that are shown. The enable property of the update button is set to the value of whichever checkbox is using this code, checked property. And then if it's checked, if checkbox lived is checked rather, then check also checkbox visited. If they've lived there, they've also obviously visited there. Now click checkbox visited and follow these steps. 0, click the events or lightning icon in the properties pane. 1, from the drop-down, select checkbox lived _ checked change as shown here, and it shows a screenshot of what you need to check or select. This is in accord with the dry principle. Don't repeat yourself. Rather than write the same code for each checkbox's checked changed event handler, let them share the same code, casting the sender to a generic checkbox so that it works for any checkbox that uses the code. That's what that sender as checkbox does. It's casting it to any checkbox, not a specific one. Finally, double-click rich text box notes and add this code in its default event handler. Rich text box notes _ text changed. And it's kind of interesting. It's setting the enabled property of the update button based on what's in rich text box notes, and it must be have some value and not just be spaces, but some actual content. What this is saying in plain English is, if the text in the rich text box is not empty, enable the update button. In other words, if there is anything in that rich text box other than white space, characters that don't display, such as by placing the cursor in the rich text box and pressing the space bar or tab key, enable the update button. So in that case, there is actual stuff in there, you just can't see it. The space bar character, the space character, the tab character would be there from the computer's perspective, but you don't care about that. If you can't see it, you can't read it, you don't want it. The code we added looks like this, and there's a screenshot of the code that's been added. Note that the checkbox lived, checked changed event handler has two references, and that's rectangled in the screenshot. This is because that event handler is called from two places, from the checked changed event of checkbox lived and from the checked changed event of checkbox visited. Allow the user to update the states table. Now we will add the code that actually updates the states table. Double-click button Update, btn Update, to open the code window in a button's default event handler. Click. Add the following code there, and it shows a fair amount of code for that operation. Now, what this code is doing, it shows the first part where variables are declared and more. This variable declaration portion of the code is interesting because we have to jump through some hoops due to the fact that the natural data type of a checkbox is Boolean. It's either true or false, off or on, checked or unchecked. Yet MySQL does not have a true Boolean type. It uses a tiny int with a length of 1, where 0 represents false and 1 represents true. So we had to have both bool variables to coincide with the state of the checkboxes and pseudo-Boolean ints to coincide with MySQL's use of such. The pseudo-Boolean ints are set to 0 by default when declared, and only set to 1, meaning true or checked, if that is the case. Most of the SQL update code that follows that is very similar to what we've dissected and discussed before, so we won't dwell on that part of the code. The only real difference is a nicety given to the user to let them know that the record has been inserted into the database. And it's a message box just showing them the message, record added for, and then the state name that they were working on at the time. And then there is a call to the clear user modifiable controls method, which simply clears the user modifiable controls so that they do not retain their values as the user navigates on to other records or rows or state. And it shows how that's done. It's pretty simple code. The check property of both checkboxes is turned false, and the text in the rich text box is made empty. And here are the updated records as shown in DBWB, after I modified all 8 states in which I have resided. And it shows a screenshot of that. The SQL that shows the data for those 8 states and the contents of those columns that we have updated. I can also check the Have Visited checkbox for all of the states except Hawaii. But this is getting monotonous, and it's time to move on to our next challenge or adventure. In the next step, we will delve into the wonderful world of relational database theory and design. See you then.